Hello and welcome to the Aronnax podcast, your regular audio insights into the transformation of the shipping and ocean space. My name is Craig Eason and I run the Fathom World website, where we report on the news about the technology, people, regulation and policies that make the maritime and ocean sectors cleaner and more sustainable. And in this special episode, supported by Lloyd's Register, we're going to focus on sustainable steel, the steel that thousands of ships are made of, and the steel that thousands of ships in the future will still be made of. Steel is an alloy. It's largely iron taken from iron ore. Steel making is a hugely carbon intensive industry and of course a huge customer of the shipping industry, as the iron ore and coal is sent to steel mills where it's melted to form crude steel and then into various grades of steel depending on where it's to be used. There are about 3,500 different grades of steel, and some of the most specific high-grade steels are for shipbuilding. There are also different ways of making steel. One is the blast furnace, where iron ore and coke, made from coal, is added along with limestone to create the liquid crude steel and so-called slag, which is in itself a useful byproduct. But this process produces large amounts of CO2, as does the next part of the process, where the crude steel is refined further to remove some of the carbon and other impurities and certain metallic elements added to create the grade of steel needed ahead of rolling, shaping and cutting. Another more modern process of steel making is the electric arc furnace, which can use scrap steel as well as crude steel, but does require huge amounts of electricity. Now, in both these processes, the steel industry is making different grades of steel, some of which is the very specific grades for shipping, grades that have to meet specific quality and thickness requirements set by the classification societies like Lloyd's Register. Shipping industry is not a big customer of the steel industry, which may be a surprise given the amount of steel used in making a ship and the machinery and equipment in it, and also considering the number of ships built every year and the numbers that are scrapped. Also, the life cycle emissions of a ship are mostly from the fuel used in its operations. So what about the life cycle of the steel? Well, as the fuel is decarbonised as we move forward, the steel production will become the next big challenge. And this is why the Sustainable Shipping Initiative has published its recent report on the greening of shipbuilding and green steel. So in this episode, we will look at how the steel in shipping can be more sustainable, how it can be reused, in some cases even back directly into the shipping industry, and why some ship owners and industry associations think it's time to start getting this issue on ship owners' minds even before the discussions about decarbonising the fuel have been resolved. The report from the SSI is the third report on life cycle considerations and component circularity. Here's Andrea Mew at the Sustainable Shipping Initiative.
We actually started looking into materials 10 years ago. So it's really not a new topic for SSI. We had a project, it was called the Closed Loop Material Management, which was really just trying to be an inventory of all the materials that go into a ship. It was way ahead of its time. And then it's kind of like got dropped off because there's a lot of effort being put into the whole fuel debate. And then it was a couple of years ago when we started getting back into this whole circularity aspect. There was a lot of work being done in circularity in other industries, but in terms of shipping, it was a bit more like quiet. So 2 years ago, we put out a report on circularity in shipping. We explored how circularity principles can be applied, and we developed a material hierarchy, and we looked into the whole R's of material management and all that, and we realized that recycling is really like the last one and the least efficient from a material management perspective. So we started looking into recycling with that report, and we just explored a bit of the end-of-life models that are currently in existence in shipping. And then based on that, we started seeing an opportunity for green steel or decarbonized steel, whatever the terminology ends up being, and then how that can be used in shipbuilding. So we decided to explore if it is something that the shipping industry can actually do, and if it is something that the shipping industry can adopt.
That's Andrea Mew at the Sustainable Shipping Initiative. Now, according to the World Steel Association, transportation, excluding the automotive sector, but including trains and lorries and ships, accounts for 5% of steel production. So shipbuilding is a small part of the steelmaker's customer base, but still an important one. And while international shipping's emissions are between 2 and 3% of global man-made emissions, the steel industry produces up to 9% of anthropogenic greenhouse gases. Steel production is, according to the International Energy Agency, set to grow by about 30% in the coming years, putting even more pressure on the environment if emissions cannot be cut from the sector. But as shipping speeds up the journey to decarbonise its fuel use in the coming decades, then the percentage of greenhouse gases associated to a vessel construction will only increase. In the steel industry, there are movements like Responsible Steel, which has now teamed up with the Climate Group to create Steel Zero to promote the industry to reduce its greenhouse gas emissions. Its signatories are companies that say that they want to procure and use green steel, thus encouraging steel makers to invest in greenhouse gas reduction targets. For its part, the steel industry has been investing in some sustainability efforts, for example in finding new ways to generate the steel using hydrogen. It's being also pushed by the financial markets, which, inspired by the Poseidon Principles for shipping, have now developed the Sustainable Steel Principles. To date, there are 6 banks that are signatories of that. So there are 2 parts to this story. On the one hand, there's the interest in using steel that has been produced with lower greenhouse gas emissions, and then there's the way that the steel from a vessel can be recycled and reused in the steel industry. The majority of large ships are built in countries like China, South Korea, Japan, but most of them, however, are scrapped in India, Bangladesh, Turkey. To be able to close the steel loop in the shipping industry would require scrapping a ship and then reusing the steel, most likely by shipping it to a steel maker for mixing with new steel. The steel industry is trying to do that in a bid to reduce its carbon footprint, but it might not make sense to do this given the emissions related to shipping steel from a ship-breaking country to a steel-making one close to a shipyard. One of the SSI members and a signatory of Steel Zero is A.P. Møller-Mærsk. Nicolo Arisano has been looking at this issue.
The Maersk focus, as well as the entire industry focus, has been on fuels, alternative fuels, since more than 90% of our GHG emissions come from fuel combustion. At the same time, the more we move into alternative fuels in the future and low carbon fuels, the fraction of the total contribution of the steel that we use in our vessel will increase and will be relevant. And considering the long life cycle and the long lifetime of a vessel, which is up to 20-25 years, I guess that it's right, and it's about time to start moving forward with the new vessels and start investigating this sector, because the focus has been for too many years, and has been for mainly on the fuels, but there are also other contributors, and the steel is one of them. From a ship owner perspective, closing the loop from the scrap, so from scrapping the vessel and putting that steel into building new vessel, is going to be a big challenge, and if not almost impossible, closing the physical loop. Because here there is an intrinsic problem that the location of the shipbuilding and the location of the scrap yards are very far. Usually ships are scrapped in Turkey or India and built in China, South Korea or Japan. So does it make any sense to ship, so to transport the scraps from India all the way to South Korea? Because probably the emissions that you get in shipping the steel are probably higher than the emission that you get from using directly primary steel. One of the outcomes of this report was to highlight how the maritime sector can still play a role in the circular economy of steel by simply plugging in the 2 ends of this linear supply chain life cycle. So when we get to the shipyard for the scrapping, we need to optimize the way the steel is entering in the cycle of the steel industry. So it has to be recycled and used and applied in sustainable and most upcycling application, because the maritime steel grade is very high. So what happens if we don't control the end of life and how the steel is recycled is that there is the risk of a downcycling. So this scraps is used in applications where not so high grade steel is needed. While at the same time, we have an issue when we are building new ships because we need really high quality steel, and so we can use only some specific type of scraps. Since the maritime sector is a small player in the steel industry, we don't need to build our own loop, our Maersk or even our Maersk loop. That's no point in that. We should simply optimize how we connect with the steel sector loop, because there are other sectors which are much bigger player in the industry, which are, for instance, the automotive or the construction sector.
Niccolo Arisano at Maersk, one of the members of the Sustainable Shipping Initiative. And that steel sector optimization that the SSI says could happen, where the shipping industry is tapped into a sustainable steel sector and the high quality steel that is taken from ships when they are broken down in the recycling yards is deployed where high grade steel is needed and not where lower grade steel can be used, even melted down locally where possible. This clearly calls for some sort of track and trace system based on verification of steel throughout the supply chain, and even a steel sector market-based measure perhaps to help incentivise green steel production. And on that point, it's worth remembering, of course, that steel production in Europe already falls under the European Emissions Trading Scheme, something that shipping will be doing soon. But there are different grades of steel, and in shipping the quality of the steel has to be high. Class societies have rules on this and already stipulate what grade of steel and what thickness can be used in shipbuilding. Here's Milene Matizevich-Clark from Lloyd's Register.
In Sweden exists, it's called the hybrid project, and this is the only manufacturing way to make, so-called green steel, where iron ore is like the main source of iron which is needed to make a steel. In order to get it, you have to, as a primary stage, you have to use reducent agent to get to the pure iron and to eliminate all the other impurities. Iron ore currently is reduced by the coal, by the carbon, as a main reducent agent, but as well it can be reduced by other manufacturing processes, at direct reduction of iron, where actually you could use natural gases and oxygen in order to reduce iron ore. What in Sweden they did, they actually used hydrogen as main reducent agent. So like that iron ore in this case is made by zero CO2 emission. And this process seems to be very promising. Using hydrogen as the main reducent of iron ore, it's kind of the future, so that we are all looking forward to, and that definitely we will bring down the CO2 emission to the promising value, and eventually we would be able to produce net zero steel. The blast furnaces will be replaced by the new processes, DRI, and electric arc furnace. So this is how in the steel making process we see the future. However, also industry now, we have to keep the competitiveness of the market. We can't just kill the industry and suddenly, cut. Blast furnaces still, of course, are in use, and the steel making industry is using a lot of initiatives how to minimize and reduce CO2 emission, especially using so-called carbon storage capture.
Is there, in the ship grade steel, is recycled steel a permissible part of that already?
Not yet. This is not yet in use, because at the moment, like a ship that it's constructed by a different, like a steel block let's call it like that. So the ship had to be cut right if you want to recycle the steel, and then this recycled steel is bought and then had to be afterwards processed. This is not yet in use. Why? Because the main factor for the design of the ship is the thickness and its classification and traceability, because normally this material has to come from an approved manufacturer. And the thickness, normally our surveyors, for example, when the ship is already in an operation, so every 2 years, I believe that they go on a shipyard when they need to verify operational status and integrity of the current ships, they're actually checking the thickness of the ship, whether to make sure that the ship will continuously operate in a safe manner. So therefore, the thickness and traceability currently are two main issues why recycled steel is not yet used. Whether this is coming, seeing that we are kind of pushed by all the regulation and the CO2 emission that normally has to decrease, because we all have to be in line with the Paris Agreement and keep the global warming below 1.5 degrees. Probably this is something that will be looked in the future. We have to monitor this, and then in this case, we would need to apply a new kind of frame of work and to give the certain procedures in order to evaluate the situation and to see whether recycled material can be used again in a ship in order to be in kind of these closed loop cycle, let's call it circular economy, as everybody is trying to do something and to do better to be in line with this agreement.
That was Milena Matisevich-Clark, a metallurgist working at Lloyd's Register. You're listening to the Aranex podcast, and in this episode, supported by Lloyd's Register, we're looking at growing interest in greening the steel industry, how shipping can tap into securing green steel, and how recycled steel from scrap tonnage can be fed back into the steel sector. And according to the World Steel Association, the steel sector made 1.88 billion tonnes of steel in 2022, of which 1 billion, or just over 1 billion tonnes, was made in China alone. Second-ranked India in terms of volumes made 125 million. The association also said that 100 million tonnes of scrap, ferrous scrap of different types of iron and steel and products, were reused back into steelmaking. And the green steel you heard mentioned is, according to the World Economic Forum, made without using fossil fuels. And one method that you heard there was using hydrogen. Yes, hydrogen, the same stuff the shipping industry has its eyes on as a fuel. The greening of the steel industry does require a move away from blast furnaces, but there are lobby groups arguing that this transition isn't happening quick enough, and also are alarmed about their new blast furnaces being planned. Now let's switch to the consumer, the buyer of the steel, in this case the shipbuilders. Netherlands-based Damen Shipyards operates a total of 36 facilities, both new building and repair and conversion sites around the world, and they build mostly small to mid-sized vessels. Damen's sustainability expert is Dewey Vesselman. She's appeared on the Aranex podcast before and was with me in Norshipping on the Blue Talk stage to talk about the role of the shipbuilder in linking the steel industry with the shipping companies.
We don't have a clear picture yet about the full life cycle. So that's really something we're exploring now. Where do actually all the materials come from? Having conversations with our suppliers, for example, the steel suppliers, like how much percentage of the steel is already made of recycled steel? And that's kind of a new question that they got. And the percentages that we get back, they can range from 5% till 95%. So that's kind of a big range. So that's also something like our current steel suppliers are actually exploring at the moment. Like, I'm not sure if the percentage of scrap steel that is already in the steel really is, how to say that, influencing the quality itself. What I know that at this moment we try to use the highest grade of steel for our vessels, even though it's like inland vessels and it might not be necessary. So, for example, if we would use more recycled steel and then the grade might be a bit lower, we could still apply it, but it's something we didn't explore yet. So that's like now having those requirements, an overview of that, and what do we actually expect from the steel grades, and how does that connect to how much recycled steel should be in there? That's really an open question that we have to explore. And I wish I already had the answer, but that's not the case.
When you source the steel, do you source the steel largely from European steel mills, do you, for your European? And then if it's in Romania or South Africa or wherever your production is, because I know that Damen has got sites in a number of different countries.
Yeah.
Do you tend to source local steel? Do you know?
Yeah, and that makes it a bit more difficult. So, for example, we have a yard in Vietnam, and there the steel is coming from China. So there we have to ask our suppliers, okay, can you give us information about the steel that you deliver to us? And within Europe, it's more known, like there is more information available. But at this moment, we do not transport like steel that we source in Europe and then send it to Vietnam, because that also has a big impact. So we source locally. Therefore, we also have a lot of different suppliers of steel.
Dewey Vesselman from Damen Shipyards. Here's Andrea Mew, again from SSI, and Nicola Arisano from Maersk on how the steel loop can be closed or linked together so ship steel can have high-grade recycled steel, and high-grade steel from shipping can be remade into the steel industry for other industries.
It's quite like localized collaboration between the steel industry and the shipbuilding industry. So maybe that could be done at smaller scale. Maybe in Europe, where shipbuilding and steel production are happening quite close together geographically. So then you can use the same steel from a ship that will go back into a steel producer and then just go back into a ship, so like infinitely recycled in the shipping industry. But then that's not really the reality of how ship recycling at least works and how shipbuilding works, because they are geographically quite far apart. So then there needs to be a better way to collaborate on closing this loop at a net level. So the steel from shipping will not necessarily go back into shipbuilding, but there could be other steel of similar qualities that go into shipbuilding eventually. So then, yes, there's a need to collaborate with steel producers, but also with other steel demand sectors that have a steel demand of similar quality. And I understand that, for example, renewable energy infrastructure is one of those demand sectors that shipping could work with.
The maritime sector can learn from other sectors which are more high ahead, let's say, in the journey, in the circularity journey. The maritime sector stayed a little bit behind because we focused completely on the fuels and the potential alternative fuels. And we're doing a good job there and it's going forward, but then we stayed behind on other parts like the circularity of the steel and the circular economy for our sector. And while you see, for instance, really advanced initiatives in the automotive sectors, which are more able to close the loop than us. And of course, we can learn from these initiatives. It can be, for instance, we are talking even about reusing specific parts, so not creating the scrap, but reusing specific components or specific parts in new builds. That's what they do in the automotive sectors. It's really hard for the ship industry because the two locations are really far, but we need to find our own way for dealing with it and optimizing our role in the steel loop. And this report is pointing to examples as well as highlighting the issues and suggesting the ways forward for closing not necessarily the physical loop, I rather say for plugging in the steel loop properly and with the best sustainable way possible for the industry.
Well, that's it for this episode of the Aronex podcast. Please remember to share and like this podcast. Subscribe to get the next episode, which should be coming out from the IMO next week after we hear from the outcomes of the intersessional meeting of the Greenhouse Gas Working Group and the 80th meeting of the Marine Environment Protection Committee. Also, visit the Fathom World website, get signed up for that newsletter, another way to get notified about podcast episodes and to get more detailed stories about what's happening in the industry. And remember, feel free to get in touch with me. Goodbye for now.